Well, hello and welcome to another DevNation Tech Talk. We got amazing things to show you guys today. As a matter of fact, we're going to have a lot of fun because we're going to talk about the non-microservice today. Let's talk about monolithic applications for a change. And actually, it's going to be kind of fun because we actually have two experts with us on the phone from Red Hat today. They're going to be talking to us about their experiences, real-world experiences they have in the consulting world, in the professional services world, with real customers, and what it means to go from that monolithic world to a better monolithic world. At least that's how I like to interpret it. So I'm super excited to be with all you guys today. Again, my name is Bert Sutter, and we're going to kick it off right now. First up is Eric Murphy. So Eric, if you could go ahead and get started and screen share.
Okay, thank you, Bert. I'll get my screen share started here. Okay, everybody should see my slides. So today we're going to talk about future-proofing your applications with modular design and avoid getting slimed by something called the big ball of mud. So my name is Eric Murphy. I'm an architect for Red Hat Consulting, specializing in application development. As Bert said, very experienced with modernizing legacy monolith applications and building microservices for our customers. And also more recently, I've been getting involved with helping our customers adopt AI ML technologies as well. Les?
On helping customers architect and build cloud-native applications. I am passionate about open source technologies and the DevOps culture, and I also maintain a blog which you can find at alesnasek.com.
Is great, by the way. So for today's discussion, we're going to discuss modular application architecture and apply modularity to both monoliths and microservices for any architecture. Also, Ailesh is going to demo a simple application modeled after Instagram that is modular. It has different features like photos and likes, and he's even going to do a code walkthrough in the demo. So next, let me talk about something called the big ball of mud. So the big ball of mud is a haphazardly structured, sprawling, sloppy, duct tape and baling wire spaghetti code jungle. These systems show unmistakable signs of unregulated growth, repeated expedient repair. Information is shared promiscuously among distant elements of the system, often to the point where nearly all important information becomes global or duplicated. So I bring this up because many applications, they start off with a great design, but they slowly evolved into big balls of mud, right? And a major way that you can prevent that from happening is implementing a modular architecture. And by the way, big balls of mud do apply to both monoliths and microservices. So Bert, today I'd like to propose that there are different flavors of application modularity. So the first one would be source control modularity. This is where you can utilize multiple Git repositories for one large application. I emphasize large application there. This allows you to scale up your application development across teams, and this is known as programming in the large. Also, number two is build modularity. This is where you can build separate projects and publish artifacts in a repository such as Nexus and Artifactory. And for Java, you may also want to utilize Maven modules, a gradual project application. Or contractual guarantees during compile time. So that's a great benefit. I know they're not commonly used, but they do help improve your code modularity. Number four is data modularity. This is where you do not want to create a tight coupling of data between your modules, such as sharing a database schema. Generally speaking, you want to have a separation of concerns with your data. So, with these 4 flavors of modularity, they do apply to both monoliths and microservices. And for building large applications, you really want to apply all 4 of these flavors if possible. But there also may be an additional flavor of modularity that only applies to microservices. So what is that? It is deployment modularity. So deployment modularity allows you to deploy multiple microservices or even serverless functions instead of one application. And this may also involve partitioning data into separate deployed databases. It requires inter-service rather than intra-service communication. So you have to propagate events using a network transport. Also, your clients or your user interfaces, they must utilize multiple services, and potentially you might want to use an API aggregator. So how do you avoid getting slimed by this big ball of mud? Well, you want to strongly enforce all the flavors of modularity, source control, build, code, data, and deployment. So food for thought, what major differences in code would exist between a strictly modular monolithic application and an equivalent microservice implementation? So keep that in mind as we go through the demo. So now I'm going to hand it off to Alesh for the application demo. And we can switch the slides.
All right, sharing my screen. Okay, so. All right, so in this part of the presentation, we would like to show you a demo application which we built in order to show you the flavors of modularity in practice. And our application is called a photo gallery, and it's an event-driven application. And we were building it to meet the following functional requirements. We have users in our photo gallery creating photos, and each photo has a name. And we also organize photos in the categories. Like, for example, we have photos of animals, photos of buildings, and people. And when the user is browsing the photo gallery, there is a button displayed next to each photo, which allows the user to add likes to a photo which he finds interesting. So we are counting the number of likes per photo. And we also allow users to formulate more complicated queries. Like, for example, users may be interested to know what are the most popular photos in each category. In order to address these requirements, we came up with the following architecture. And you can see here on the diagram that we are having the application broken up into 3 microservices. We have a photo service, a like service, and a query service. And each of the services has its own dedicated storage. Photo service has its photos database, like service has its own, and the query service has its own data store as well. Now, to give you an idea how the services are communicating with each other and how the application works, let's take an example where the user is creating a photo. When user is creating a photo, it sends a post request to the photo service with the information about the new photo in the body of the request. Photo service will store the information about the photo in its own data storage, and it will also publish a message with the information that a new photo has been created, and it will send that message through the message broker. Similarly, when the user is adding likes to the photo, he sends a post request to the like service. Like service will bump up the counter of the likes for the given photo in its own database, and it will also publish a message to the broker with the current number of likes for the given photo. And then we have a query service here who is listening on the broker for the messages coming from the photo and the like service. And based on the information coming in the messages, query service is preparing its own data store to be able to later answer the queries about what are the most popular photos for the given category. So I will now come back to the modularity principles, which I'm showing here. So the first one Eric talked about was the code modularity. Here you can see that we do have 3 independent modules: the photo service, like service, and the query service. And these 3 services are decoupled and are only communicating via a message broker. Regarding the data modularity, we do have each service having its own dedicated data store. Services are not directly accessing each other's data. On the next slide, I'm showing you a more detailed view of how the persistence layer or data model looks like. The photo service is maintaining a table where the photo is identified by a photo ID, and we save the name and the category. And the like service is just storing the number of likes for given photo ID. Query service is preparing and storing all the information or data it needs to be able to answer the more complicated queries. After the first two flavors, I'm going to now show you the next 2, which is the source control modularity flavor and the build modularity. So regarding the source control modularity, we do store, or we do use, multiple Git repositories to store the source code for the application. The photo gallery common repository, that's where we store all the common definitions, which are actually shared by multiple modules. And we also have the gallery monolith repository, which doesn't contain any source code, but it actually contains a POM file for Maven to be able to build the monolithic application using the 3 modules, photo, like, and query. So before we go to the last modularity flavor, let me actually show you how the photo gallery looks in Eclipse. And for that, I will switch the window here. So I imported the source code for the photo gallery into my Eclipse editor. And the first project I will show you is the photo gallery common with the common definitions, which are shared by multiple modules. We have constants here defined. These are the names of the queues where the messages are published. And we also have the format of the messages in the form of beans. Here in, for example, photo created message looks like this. So this information, or this classes here in the photo gallery common project actually shows how the 3 services are coupled. This is the only coupling they really have. This is the format of the data which they need to all understand. If I show you one of the other services, let's take the photo project. Photo is, or all services are written as a Quarkus application. There are REST services. You can, for example, see here the photo service implementing the photos resource. And there are 2 methods which we implemented. The first one is the post, which creates a new photo where user passes in the data, which is immediately parsed from the JSON body, and we store it in the database. And after that, we create a message, which we publish here to the topic, to the browser. The second method which we implemented on the photo service is the method to get all photos from the database. Here, user sends a simple GET request, and we create a query to select all the items from the database, and we, on this line, serialize them into JSON and send them back in the response body. And one more thing interesting here is the photo gallery monolith, where, as I said, there's no source code. There's only a POM file, which now takes as a dependencies our 3 modules and you builds a complete monolithic application. So coming back to our presentation, let's take a look at the last modularity flavor which we were presenting or showing today. And this is the deployment modularity flavor. Our application, as it is written, can be deployed in two ways. Either you can deploy it as a monolith, or you can deploy it as a set of microservices. And if you choose to deploy it as a monolith, what you will get is a monolithic process, which is running, or which consists of all three modules running inside of that process. And the three modules are communicating over a vert.x event bus. And in this case, it is a in-memory communication. So this is not really a distributed application. All communication happens quickly in memory. And this monolith now exposes one API endpoint where all three modules, the photo and the likes and the query modules are accessible. And you can indeed scale this monolithic application by replicating the monolith itself. And you can also see that we are using one physical database. However, each of the modules has its own database schema, so there is no data sharing underneath. The great advantage of this kind of deployment is that you are avoiding the downsides of distributed systems, like, for example, unreliable network communication and others. Now, if you want, you can also deploy our application as set of microservices. And in this case, you will get 3 microservices where each of the module is running in its own separate microservice or process. And these microservices are, again, talking over the vert.x event bus. However, this time it is a clustered event bus, which is really distributed and sends the messages over the wire. Now, this brings in the entire problematic of distributed applications and the reliability of it. Also, each service will expose its own endpoint. So the user will need to somehow be able to find out about all 3 endpoints. For example, you could put a facade in front of our services, or maybe an API gateway, which would be able to expose all 3 endpoints in one single API. And regarding the scaling, the big advantage of this approach, this microservices approach, is that you can now deploy each of the services independently. It means update them independently without touching the other ones. So if you are interested, you can find the source code for the photo gallery on GitHub. And one more demo I have for you is I would like to show you how this looks deployed on OpenShift. I have 2 projects here for you to look at. The first one is the photo gallery monolith, which contains the monolithic deployment of our application. You can see that we have one monolithic process connected to a Postgres database, and you can indeed scale the monolith. You can have multiple instances of it. If there is more load coming into your application, no problem. And you can also see here in resources now that there is this one route where all 3 modules, the photo, likes, and query, are accessible. On the other hand, in the project here called Photo Gallery Distributed, I have deployed the distributed form of our application, where we are having 3 different microservices, each of them connected to its own database. And you can now take one of those microservices and scale it independently, and also deploy the new version independently of the other microservices. And as you can see here, each of the microservices will be exposed on its own route. Coming back to the presentation, This will leaves us with the conclusion part. So Eric will draw some conclusions for you. I will stop my screen sharing.
Hey, Alesh, since I was having audio issues, would you mind covering the conclusion?
So we'll run my screen sharing again. All right, so the basic takeaways from our presentations are that you've seen an application where the same code is deployed in two different ways. We have a monolith deployment with the advantages of the monolith, but also disadvantages of the monolithic deployments. And you've seen also the microservices deployment. And we implemented the 5 flavors of modularity, where the first four ones are, I think, acceptable or are good for everybody. With the fifth one, where we are talking about the deployment modularity, you can make your choice based on what you want to achieve. If you prefer a monolithic deployment, or if you would prefer actually to go all the way to microservices, because we definitely know that microservices has also its downsides. And we were showing in this example how vert.x event bus can be nicely used and works in both of the types of deployments out of the box. And when you are building your application, you want to consider building it first or deploying it first as a modular monolithic application, and perhaps see later if you want to actually deploy it as a microservices, if there is the advantage to gain from it. And if you want to find out more, you can follow us. You can see Eric's Twitter and my Twitter, and you can also find more information on my blog at aleshnosek.com. And you can also contact Eric on his Red Hat email address for further questions. And thank you for looking at our presentation.
All right. So Benedict had some interesting questions. Let's try to discuss Benedict's questions here. One was, is the broker in memory? And I believe the answer to that is yes, because it's the vert.x event bus. Is that the broker in question that was on your slide?
That's correct. The vert.x broker works in the process in memory. And the only difference between the two deployments was that the monolithic, the communication goes also in memory, while in the distributed deployment, the messages are actually sent over the wire.
Right, but it's still, there's no actual physical broker.
There is no physical broker separately. Yeah, there is no such thing. Yeah.
Okay. And there was a question around MVP. Does that mean model view presenter or minimal viable product?
Minimal viable product. We put this together with Eric for the demo.
Yep. Okay. And we already added the GitHub repo for the sources. That'll be in our chat. I can add it again, but we did add it once. And then, but Benedict had another question that I think is very important, and that is related to, can you actually define in a very quick way, what does it mean to decide between the monolith, the modular monolith versus microservices? What are the trade-offs? When do you make the decision to go from one to the other?
Yeah, that's a very, very good question. Let me start with the most kind of important things. With monolithic applications, you get a big monolithic application running, which kind of avoids problems of distributed systems, like, for example, unreliable network communication between components. And also, with monolithic applications, it's easier to work with your data, whereas in distributed fashion, you typically have each microservice kind of working with its own data, which you then need to keep somewhat in sync. With the distributed way of deployments, what you will get and what people most benefit from is the ability to independently deploy separate or individual microservices into production separately. And also people tend to organize their development teams where each development team is, let's say, responsible for one or several microservices. And you don't have, so you can scale out your development that way instead of when you have a monolithic deployments. You have you have the source code of many people in that monolith, which is now being deployed, which then leads to a need for synchronization between people.
Okay, Eric, anything to add there?
Alex did a great job of presenting that. Definitely, scalability is a concern on why you would want to go from a monolith to microservice. That being said, with Quarkus, for example, as a new way to deploy Java applications, you can create many more instances of your application in OpenShift for scalability, and that applies to monoliths or microservices.
Mm-hmm. Yeah, I was curious, with the monolithic deployment, did you guys compile all the way down to native using Quarkus? And if so, how much memory was it using?
So this is a Quarkus application, which is we are running it on JVM. There is one interesting thing about the memory consumption and the JVM. We know that when you are using Java 8, the memory consumption is very much dependent also on what you set as a max heap size for your application. So it's really a trade-off, right? If you let the application eat more heap, the application will definitely use it. While if you want to kind of save on the memory, you might set your max heap size to lower values and keep your application consuming less. Now, indeed, as a monolithic application, you will actually have only one heap, which is better than having a distributed application where each of those microservices is now having its own heap and its own JVM.
Okay. Now, there's some questions related to the database. And for instance, Alexander had one related to database modularity. In database modularity, you show a close coupling of data through the sharing of IDs. Do you know of any ways to avoid that?
So I'll try to take that one. So typically with distributed systems such as microservices, you want to use a universal identifier, a UUID. That's how you can create the relationships between the data logically. So there may not actually be a physical connection inside of the database through foreign key constraints, but collectively, that there will be a relationship between the data. Does that make sense?
Yep. I like the UUID answer. That makes a lot of sense to me, and it's applicable even if you actually use something other than HTTP to distribute your application, right? It could be a Kafka-based backbone to distribute the application, or like you guys did with the vert.x event bus. There are 3 separate schemas for the 3 tables or collections. Is that an overkill? Or is it really, really needed in order to avoid future BBOM? I'm not even sure what BBOM is.
I'm not familiar with that acronym either.
Yeah, it's an interesting.
But generally speaking, if you have tables that are in one schema, the developers or a DBA, they're going to be very inclined to create those constraints, those relationships between the tables that will make it more difficult to separate them out into separate databases in the future.
Okay.
So that's the reason for having multiple schemas.
Right. And actually, for people interested in database, I'm pasting in the link to our free ebook that talks all about how to deal with the database in this microservices, modular, monolith world. If the database is your concern, then there's a ton of strategies, tips, and techniques in that free ebook written by Ed Sayanaga. I encourage you guys to check that out. Now, there's another interesting question that I think is very appropriate for this conversation, and that is, if I want to deploy one of the microservices but they're in the modular monolith, is that possible? So in other words, you guys have the photo gallery like as an example. Can I deploy like without deploying the rest?
So I believe the question is about, can you break them off one by one? Is that correct, Burr?
Well, no, it actually is about deployment. So and I think the answer is, if it's a monolith, it's a single monolithic deployment. If it's a monolith, you have to go to microservices if you want to separately deploy the individual components. Yeah. That's still true?
Yes.
That's right. Yeah.
Okay. And the BBOM, by the way, was big ball of mud, which is funny, right? Because you guys started with that phrase and I just couldn't think of the acronym. Okay. And we are officially out of time, but there's one last question we'll throw you guys' way. What about a best practice for strangling an existing tightly coupled monolithic application? Do you guys have any quick tips or tricks on how to deal with strangling that big old ugly tightly coupled monolith?
So one thing I would say is you can take this legacy monolith that maybe a BBOM and try to make it more modular as a monolith first, before you begin to separate off the microservices into independent deployments. So you can, refactor your existing monolith and make those improvements incrementally.
Yeah, and that's a good idea. And I would add to it, you also, if you are then splitting out microservices, you maybe want to start with a low-hanging fruit and split something what is simpler and is not too much coupled with the monolith. And then when you have already a monolith and a microservice running next to it, you can kind of feel the distributed systems problematic and decide later how far you want to still go.
Okay, well, we are officially out of time. I apologize that we can't stay on longer with you folks, but it was a nice, engaging session. And I enjoyed the little application, by the way, because I actually, while you were talking, I Git cloned it all and I did the build on my local machine. So, I haven't tried to test it properly, but I did get it all to build. So that's a good sign by itself. So thank you all for today. If you have further questions, feel free to reach out to Eric, Alesh, or myself on Twitter, or you can always find me on email. You guys got an email from me to even show up for today's event. So you know my email address, and I'll pass that on if we have questions in the future. But thank you again for your time. And thank you guys. Everybody have a good day.
Thank you.